Hi everyone, thanks for joining us today. This event is brought to you by Data Talks Club, which is a community of people who love data, and we have weekly events. This event is one of such events. You can find out more about the events if you go to our website, datatalks.club/events, and you'll find all the events we have in our schedule. We have two types of events, webinars and live podcasts. So today we have a webinar. So just go there and check. We have quite a few talks lined up. So they are all awesome. Don't forget to subscribe to our YouTube channel to stay up to date with all our events and join our Slack where we have amazing conversations about all things data. And last but not least, if you have any question during today's conversation, during today's presentation, there is a pinned LinkedIn live chat. Go to that link and ask your question, and then I'll be asking these questions at the end of the presentation. That's all from me. And now the floor is yours. You can start.
Thanks, Alexei. So I'm going to take over the screen share now and just share my side as well. Before we kick things off, I just want to do quick introductions for myself and also for one of my good friends, Srivathsan. So my name's Alex Chung. I used to be a product manager on AWS SageMaker, and my role within the team was to specifically target the larger, typically publicly traded Fortune 500, Fortune 1000 type enterprises and convince them to leverage our machine learning services. So SageMaker is considered an end-to-end ML platform, but each tool within it is individually usable, isolated from the other services and pieces. Similar to if you go to any of the different startups today that focus on ML ops, you can use their service, but you have to bridge it with all the other tools that you need for an entire model lifecycle. Before Amazon, I was working at Facebook for the computer vision data ops, and I also ran a hedge fund that applied machine learning as well in emerging market debt. I'm going to hand it over to Srivathsan, who I met while I was at AWS.
Hey, good morning. Thanks for the intro, Alex. My name is Srivathsan. I work at Intuit, and until recently, I was the head of engineering for Intuit's machine learning platform, where we built an ML platform that leveraged SageMaker under the hood and provided entire lifecycle services for our machine learning operations. Prior to that, I used to run an engineering team which built out Kubernetes-based infrastructure at both at Intuit and at eBay.
So Srivathsan and I have done a number of talks within the AWS ecosystem. We did a re:Invent session together talking about some of the ideas of enterprises building their own ML platforms and augmenting with SageMaker capabilities. And we're now really starting to discuss this new trend that we're seeing. The audience and the personas, I think, will really gravitate towards orchestration of ML workloads across tools and also across cloud platforms are going to be larger organizations, typically 25, 50 plus data scientists or more. I think Srivathsan can share a little bit about Intuit's profile in a bit. But when you're at this stage, typically speaking, you're not using one ML platform for everything. And when I say one ML platform, I mean one set of tooling that's either backed by one vendor, all built by one central team within your company, or one open source de facto tool that aims to do all the different pieces of the model lifecycle. And the fact that we've observed that in large organizations, no single tool can do it all comes from this fact that the ML ops journey isn't one thing. It's actually made up of smaller bits and pieces. I call it the big 8. I classify it as 8 stages. AWS Marketing Materials will call it 4. If you go to Azure's websites and also some of their papers, they consider it 9 steps. But the distillation is data collection, data processing, feature engineering, data labeling, model design, model training, optimization, and then deployment and monitoring. Each one of these individual stages are unique products. They don't overlap at all with the other. At the same time, they do need some degree of interconnect. And that's why many companies and many people who talk about ML ops and tooling platforms describe it as a platform, but there's many individual layers similar to how we think about Kubernetes. There's the main control plane, but you have to add in all these other elements like an Istio for networking, and then there's other deployment systems like Argo CD for managing your deployment jobs. MLOps platforms are very similar in that regard. And the tricky piece here is, how do all these different elements interconnect together when we have the different stages of the lifecycle present in an enterprise? So for instance, if you have a model endpoint and there's a drift on the model, this basically needs to either alarm an engineer to go re-kick off the training jobs, the data processing, and then deployment of a new model, or this needs to happen semi-autonomously where it goes back and collects new data and then feeds the processing engine, perhaps go through another set of labeling before doing this programmatic redeployment. The whole MLOps ecosystem is almost a game of chutes and ladders. It's not always you go across bit by bit, you go back and forth. And in a large organization, when there's multiple teams, there might be multiple ways to do one stage. For example, for GPU accelerated inferencing versus classical ML inferencing, you will likely have two different systems that do the model endpoint serving, just because it's not efficient to have it all leveraging one type of utility or library. And this always goes back to the classic question of, do you want to build tools yourself, leverage open source libraries, or buy from vendors? When you have the MLOps 8 stages, it's a confluence of different factors. And that means when you also integrate it with the 3 different ways that you can build these MLOps stages, it becomes actually a hodgepodge of different tools that you're going to have. And none of them are backed by a single party. None of them are backed by a vendor. None of them are maintained by the open source community. And none of them are all owned by the internal ML platform. It's a bit of everything. And Srivathsan at Intuit has been really brainstorming about this idea of orchestration. And I'll let him explain some of these concepts a little further.
Thank you, Alex. So I wanted to start with a little bit of a backstory on orchestration itself. And we've seen a pattern in multiple adjacent areas. I've come from the cloud and Kubernetes background, so that area is something that's very familiar to me. So in the cloud infrastructure, we see orchestration being performed by tools such as Terraform, where you can, large organizations can actually create their cloud infrastructure and in a portable manner, so that you can actually go from AWS to Azure, or you can have mix and match of those, and you can orchestrate within those tools themselves. Similarly, for Kubernetes cluster, there are tools such as Rancher and Tanzel, which are doing similar things, and Prefect and Snowflake in the data pipelines world. So we see an opportunity for orchestrating inside the MLOps ecosystem, the big 8 stages, as Alex was explaining, by providing a common set of toolings that will allow to mix and match all of these stages and go through all those feedback loops that you saw earlier in the presentation, and be able to orchestrate all of these in a way that fits the current team or the current model and so on. So many large companies we've talked to, and it's a case at Intuit as well. These companies invest in sort of a ML platform where there is some there are these orchestrators that get built up. Can you go back to the last slide, Alex? Yeah, and then the idea is that there is an ML platform SDK which allows for a data scientist or an ML engineer to have a consistent interface to all the stages on the right, which is the data collection, processing, big 8, and provide certain boilerplate functionality such as data and artifact storage, metadata tracking, auth or Z that applies to that particular organization, and stitch all of them together in a workflow orchestration. And we see that this is an important aspect of ML ops, and that's something that companies internally are starting to build. And increasingly, this is needed in order to democratize ML, because data scientists and ML engineers now do not need to learn all the different ways of implementing the right-hand side. They need to work with the SDK and learn how to work with the SDK, and then they get all the capabilities on the right. Let Alex talk about some of the vendor spread in ML ops.
So like what Srivathsan mentioned, large organizations are building up and standing up these internal ML platforms. And in many cases, they're building certain stages of the Big 8 as part of their ML platform as well. But because these organizations are relatively large and have multiple subunits within the organization, that means different teams with different business owners, different internal IT architects as well for their cloud platform, it is consistent that these ML platforms also leverage different vendors to augment their internal capabilities. And the reality is, comes back to this idea that nobody can do it all. Earlier this quarter, I spent some time going through a list of all the different features that I think were relevant for a modern ML enterprise to need to have access to in order to have what I would consider a robust ML platform. It's things like being able to do training on Kubernetes clusters, which today is actually fairly challenging to do on SageMaker, and even to some extent GCP Vertex, even though they're trying to advance more GKE usage as part of their cloud ecosystem. But things like also data versioning. If you go to model inferencing, it's the idea of being able to do inference graphs, which allow a data scientist to ensemble different models together for a final inference in a specific workload. A lot of these features are actually missing. And the startups have many of these best in breed features, but the large end-to-end ML platforms have the most breadth. And this dichotomy and split of end-to-end versus best in breed is this interesting mix that together, if you could unify this for your data scientists so they can move between either the end-to-end ML platforms or the best in breed tool in a unified manner that isn't opinionated to the individual tool, but is opinionated to a meta SDK, this internal orchestration library. That's where many ML platform teams have now moved towards. And we see this really as a trend that will continue to accelerate. I work closely with Morgan Stanley on various interesting projects and finance-related asset management goals. But one of the surveys that I had reviewed with them was this idea of CIOs wanting to mix and match, which is even different from, I'd say, managers or individual ML engineering teams in large enterprises. CIOs set strategic direction for the entire organization and are beholden to the long-term business goals of the entire company. And they're already thinking very closely about AI, ML in the two camps I described. There's the combination of best tools, i.e. best in breed. Over half of CIOs are already going in that direction. And then there's the other half that are interested in using a public cloud service for their ML platform. But if we ask this question, looking at the data orchestration and their data warehousing to the same set of CIOs, what we can see very clearly is that a large portion, this middle two segment, so about 62%, are interested in using the best in breed, the third-party cloud data service, or a mixture of all the options, which means a little bit of everything within their entire company. And those that are exclusively using the public cloud service drops to about 10%, which means over time, if we see that the data warehousing market is going to be similar to ML ops as ML becomes more widely understood, this idea of mix and match will continue to grow. And I attribute this to the idea of a tooling sprawl. If you look at CNCF's Kubernetes toolkit in terms of startups, open source tools, and different projects. It's a huge mass grid of different names. In MLOps, I assembled my own version of this. It's already fairly similar. It's a huge hodgepodge of different tools. And these are the ones that I actually see enterprise usage of. If I also throw in the startups in here as well, it would augment this graph and table even more. And when I look back to the direction of large enterprises and this idea that they will mix and match, for the foreseeable future, these startups and also existing enterprises won't be able to do it all. And if they can't do it all, if we go with that assumption, these tools, whether they be open source from a vendor, they will need to integrate with what enterprises are building internally to orchestrate all this mix and match. And this is where we introduce the idea of orchestration utilities. For any of the developers, it's always going to be the classic problem of there's competing standards and competing ways to do things like model serving and model training. And essentially, these enterprises have pretty much said, we want to build yet another standard, another SDK that can cover everyone's use cases and integrate it all together. So I made a twist of this classic XKCD meme that pretty much says, oh, there's 14 competing standards. And then the VP engineering says, ridiculous, we need one that covers everyone's use cases. And of course, the CIO says, yeah. And then what actually ends up happening is the vendors and the open source contributors are now struggling to figure out how to integrate their libraries and SDKs with all these internal standards. Within SGT, so the nonprofit that's focused on MLOps that I'm building up, we're collaborating with enterprises like Intuit and several other large publicly traded organizations. And we're working on actually developing these tools in open source. And I'll let Srivathsan wrap up of like just some of the use cases and the value of how these orchestration tools can provide for ML teams. And then we'll talk a little further about what we're doing within the open source community and what our ambitions are for the project MLctl.
Yeah, thanks, Alex. So I think the key thesis is that we want to make sure that ML engineers and data scientists are able to focus on their code and not worry about the operationalization and the glue that needs to happen in order to take their models from code to production. In this picture before there here, you can see that if you want to deploy to, let's say, two clouds, the two layers here are two different clouds, you want to be able to write the glue code so that it corresponds to that particular deployment system's parameters. For example, if you're using SageMaker, then the containers need to be built in a specific way. Versus if you're using Azure ML, your containers need to be built in a specific way. Versus if you're running on Tecton or on Kubernetes, raw Kubernetes, it needs to be built in a specific way. So all of this is glue code and grunt work that model developers or data scientists and MLEs are not equipped to do, or they are not most familiar with it. So this is where the MLOps tooling which will be able to bridge the gap between the data science teams and the backends that that are supported at the enterprise. So this can lead to a wide variety of tooling being used interchangeably within a particular company, and with still the right levels of operationalization, monitoring, and so on, while allowing data scientists the flexibility of using tools of their choice. For example, team one could use Spark with MLflow for tracking and SageMaker for training, and maybe Kubernetes for batch inference. Team two could maybe using Airflow for orchestration, some batch in AWS, and on-prem for everything else. There could be another team who's all in on Kubernetes and Kubeflow, and they're just using that. The interfaces to these systems, can they be the same, and can they be similar, so that from a user perspective, this complexity is not apparent to them, and they can focus on the work that they need to do. In addition, can the MLOps orchestration layer also provide boilerplate functionality such as data processing, metadata tracking, and so on, so that in a consistent manner across these systems? Can you go to the next one? Yeah.
Oh, that's all we have. I'm just going to leave this slide here just to let the audience continue thinking about this idea of an orchestration SDK. This was the major problem that I saw when I was at AWS. Across the dozens of publicly traded large companies that aren't a Facebook, because a Facebook can just build everything on their own, but not quite a small startup, and also that has a reasonably sophisticated engineering team with a mix of PhDs, full stack engineers aiming to be doing the ML platform work and ML engineering. This orchestration SDK is essentially developed by every single one of these independently run ML platforms within these organizations. And our goal has been to now figure out within open source, how do we build an equivalent version of this? So Srivathsan's team has been able to open source ML Cuddle. It's similar to Kube Cuddle in terms of naming, but focused on the ML ops stages. And that's been happening in development across just on GitHub. And also we have the Slack community that we've been working on, where collaborators can work together. And we've been working with several others individuals, and we've been building this out so that this could be one of the paradigms for how ML platform teams, and by extension, their data scientists, integrate with ML ops tools going forward. And when we think of the ML ops tools, we really mean the projects or libraries or vendors that handle each one of these individual big 8 steps. This ML platform SDK that we are working on, called ML Cuddle, aims to really be essentially a Terraform for the ops jobs. So for each workflow that you have to create, it wraps to a ML Cuddle paradigm, and then that translates down to what a SageMaker will need, or what a Kubernetes pod would need in order to run the workload, including where to pull the data from, and then where to save the data, and the other boilerplate hooks that need to go along with it. The ML flow versus weights and biases integration, or for model monitoring, emitting all the inference logs to either Splunk, Datadog, S3, or a more sophisticated solution like Fiddler, Arise, or a similar start in that regard. So ML orchestration, this is where we believe the next trend will be for ML ops. It's really trying to coalesce and manage the tooling sprawl that ML ops has become the last 3 years or so. And hopefully it paints a clearer picture for new developers into the industry of how they can have a lower entry point in terms of understanding how to access all these different tools and services. But for enterprises, it means you have better governance, because you can have a central way to track all the workloads coming in. And also, in addition, you can increase velocity because you're standardizing the data science and model code to one template, one contract. And then from there, the platform teams can update the plugins from their do-it-yourself infrastructure to their internal orchestrator, or the vendors can integrate with this open source ML platform SDK. And that's really what we have today in terms of discussing ML ops orchestration libraries. I think this is something that we've seen consistently in large enterprises pop up the last 18 months, but really this year towards the beginning, that's where I think we really saw a huge influx of customers thinking about managed services and also open source, and still having a lot of legacy do-it-yourself built MLOps tooling. And we'd love to invite the community here to reach out to us either on LinkedIn. So I'm Alex Chung, and then Srivathsan and I will both put in our LinkedIn to the description and chat later on in this seminar. And we'd love to engage in conversations with people who have the need for large ML platforms, and thus by extension have a mix and match of different tools and services. And we can discuss like some of the trends that we've also seen specifically for the patterns that we plan on building into MLctl, but in addition, how we've seen other enterprises manage this complexity as well. Alex, I'm going to hand this back over to you. We really love to participate with others in the community if they have questions and just comments in terms of how we're thinking through this ecosystem and how this is evolving for the ML journey.
Yeah, so far actually there was only one question, if you're going to share the slides. I think the answer is yes, because yeah, why wouldn't you, right? So, but so far, yeah, I don't see any question. Just want to remind, if you want to ask a question, there is a pinned link in the live chat. You click on this link, brings you to Slido, and there you ask any question you want. And yeah, while listening for your chat, I also, we OLX, we are one of those enterprises you were talking about. Like we're not that yet like Facebooks and Googles, but we're a relatively large company with all these intricacies. So immediately recognized like everything you were saying. Like I saw that we also have many teams with many different tools, and yeah, we actually, like you said, we ended up doing some small tools around that to wrap them around to somehow connect them. That all sounds familiar. And the question I have is maybe like, okay, like what to do with this? Like, is it the right direction, or because it seems like all these tools do need a lot of glue code. We need to write the code, but like, should we maybe try to do it with some open source tool, or like how does it usually work?
Well, this is a combinatorics problem. The number of good solutions out there, and then the number of combinations of those good solutions. So if we look at the big 8 stages, presumably it's an n choose 8 and a basic combinatorics, which explain that that's a very, very large number. But the reality is that n is probably a little smaller, maybe about 100 different tools out there. If we look at like do-it-yourself, that's internal to an enterprise, but also what's available. So SageMaker, GCP. The long tail is the fact that there's the 8 stages. And that means if we talk about data warehousing for data collection, you span from a data lake or a data warehouse, so Redshift, Snowflake, et cetera, all the way down to amorphous data, computer vision or speech, where you might be connecting to Scale or Mechanical Turk to do large scale collection of your data. And this becomes a lot of those glue code connectors.
Exactly.
And that long tail means either your ML platform team stands it up and maintains all that, which is going to be very challenging, because it sounds like for OLX group, you guys probably have hundreds of data scientists, maybe also
but yeah, like a good number.
Dozens of data scientists, probably another
Yes.
dozens of ML engineers. It's your ML platform engineering team that supports those first 2 personas is probably 5 at most, maybe even less than that.
Yeah. How did you know?
I'm just doing guesswork here, because this is like the themes are very similar. Like Srivathsan, what's it look like at Intuit?
It's very similar. So we have 300 to 400 data scientists and a team of 15 people running the ML platform, supporting the entire data science team.
So the ratio is almost like 1 to 25, right? Something like that?
Yeah, something like that, yeah.
And this becomes the biggest problem for large enterprises. And that's why we're really focused on large enterprises. Happens to be my background and where Srivathsan comes from. But over time, as MLOps evolves, we can think of this as the new entry point to make MLOps more accessible. For instance, for an application engineer, if they want to learn Kubernetes, they could. Or they could go straight to a Helm chart that's packaged by an SRE team or a platform infrastructure IT team that's given to the application engineer. And they, in an ideal state of the world, are modifying a few config files and then throwing in their whatever code, JavaScript, Python, etc. And then they deploy that Helm chart. That's where we see the direction going in MLOps. The exact modality and like the puzzle pieces are going to be slightly different, but that's got to happen because otherwise, if you're deploying on SageMaker, which I think right now, if you're on AWS, is one of the fastest ways to do it, you have to learn SageMaker. But many organizations that grow up quickly outgrow SageMaker or only use bits and pieces of SageMaker as they need other complementary solutions. Like, what have you seen, Alexi? Like, did you start with a managed service and then go more homegrown? Or are you guys also looking at vendors?
You describe it pretty well. So we started with SageMaker, then we realized that at some point, okay, this is getting a bit expensive. So what are the options? And then like we moved some of the stuff, the more expensive ones, to some other, like the serving part, for example, we moved it to Kubernetes, the training part stayed and SageMaker. But then with SageMaker, there is SageMaker Studio now with all these different tools. We don't necessarily need all of them. Like, for example, SageMaker pipelines, it's nice, but we now use something else for pipelines. And then at the end, we have this Frankenstein monster that, you know, we need to, like, training happens in SageMaker. Pipeline happens like, I don't know, we use this CI/CD, GitLab CI CD, like all these different things, we need to put them together, right? So SageMaker, this GitLab CI/CD, then serving in Kubernetes, then use also Airflow to orchestrate some of the things. And then, yes, it becomes like this Frankenstein monster with a lot of glue code. And of course, each team also has their own needs. Like there is a team that needs to connect to get some, you know, involve humans in the loop. So they have special solutions for that. Some of these are in-house. Some of them need to connect to some external services for doing that. It's a lot of blue work, right? So there is no platform that we can just take and use because it doesn't exist, right? So we need to do a lot of stuff.
Yeah, I think the way we think about MLctl is the job itself is the lowest common denominator. So if you ignore the workflow orchestrator, so whether it be Airflow, Kubeflow pipelines, or if you use maybe something else like SageMaker pipelines, ignore that for a second. That's just constructing a DAG. The job itself is the unit of, let's call it like portability. Like if we just move the job over, that's really, really what we care about. And a job can also be defined as a node within the DAG. And that is either training, that's deploying to a serving system. It's also like the data processing, whether that be Spark or just in a container that's running, you know, a computer vision data processing library. If you can move those around, I think that's where a lot of the value is, because that's where the data scientist is doing a lot of the manipulation of the code. I think most people have learned that constructing a DAG for a majority of use cases is actually pretty simple in Airflow or Kubeflow pipelines. It's like the actual code itself that's being run that ends up having a lot of complexity. So what Srivathsan and I have been brainstorming is integrating MLctl as a component within Kubeflow pipelines, and also providing a very similar interface as a Airflow operator, which means it runs our MLctl transpilation process, and then from there, MLctl will route the job to SageMaker. Basically, it makes Airflow almost a portable solution for your MLOps tooling infrastructure. And then we have various libraries packaged within the MLctl container that we build that make sure that all these different systems can talk to each other.
So MLctl, actually, I thought like all this time I pronounced it as this CTL, not Cuddle, like kubectl, not kubectl.
Up to you.
Yeah,
Is it kubectl or kubectl or kubecontrol?
Yeah, control. Okay. So anyway, so this MLctl, like what does it actually do? Like from the presentation, I think the impression I got is that like all the problems you described, like this orchestrating different tools, MLctl is supposed to solve that, right? To help integrate all these different things, or not? Did I get it right?
Srivathsan, you want to take a first stab?
Yeah, sure. So MLctl provides this uniform interface to data scientists and MLEs. So you can do things like MLctl init, just the simplest thing, right? Which will provide you with a boilerplate model that you can then start putting your code in. And then you can say, okay, I want this to be a decision tree. Here is my code for the decision tree. And then you can do MLctl build. And with the build, you can start putting in a target saying, okay, I want this to run on SageMaker. So target is SageMaker. So build this for SageMaker. Mm-hmm. It's like saying in the C++ worlds, you can build it for a specific target. You can build it for x86 or ARM or something like that. That will build this universal container with a lot of the tooling that goes in for that specific target. And then you can say MLctl train run with a specific target, and that is going to run the training on that. So you can run training on SageMaker, you can run training on Azure ML or Kubernetes. The interface to the data scientist remains the same. The plumbing behind the scenes of, hey, how do I connect this MLctl to SageMaker or to Azure ML for my organization? Because my organization has specific things in terms of auth.z, how do you do authorization, role management, and so on. Those are the things that the small ML platform teams, like the 5 to 10 people team, will be responsible for making those connections behind the scenes, so that the tens of data scientists don't have to learn about all those connections, and then they can continue to use this interface to orchestrate their machine learning jobs. And extending on what Alex said about using this in whether you want to use Kubeflow pipelines or Airflow or any other workflow orchestrator, you can start plugging this in natively into those workflow orchestrators. So you have the best of using the workflow orchestrator of your choice. Then the organization has the choice of using any vendor or homegrown solution for the big 8 stages. Then the data scientists have a consistent view of the world.
So the word that we like to use is contract. It's the contract between the platform engineering and the data science and ML engineers.
So did I understand it correctly that so this tool lets you, I don't know, quickly deploy on SageMaker or whatever tool, but if there is something homegrown, like some internal system, that you can also quickly write, extend the tool, MLctl, and then it will also deploy to the, what is it written in? Like, is it Python or?
It's Python. It's Python, and it is it has these interface points for training, for prediction, and so on. And you can write extensions for a homegrown. Let's say you want to run training on your on-prem infrastructure, and it's a custom service that you've built. You can write a connector which connects with MLctl and interfaces with that.
So if we think about it, right now, what MLctl does is it interfaces with the Azure ML SDK and also with the Boto 3 for AWS SDK. And what we first do is we take the job that the user defines into our pseudo intermediate representation. And then the plugins read from that intermediate representation of the bits and pieces that it needs. So for example, where the data is, what's the job name, what is the metadata connectors that need to be used. And then we put that into the Boto 3 specification, and then it runs the job on SageMaker. And that's what our current early version is. And the plugin extensibility can augment the existing large cloud platform plugins that we already have as well.
Well, it's good it's not in Go, because all these Kubernetes CTL Cuddle tools, they're all in Go, like kubectl. Oh, I keep saying kubectl because this is how I am used to calling this. Yeah, so I was afraid you would say it's also Go, so it's good. Actually, there is a question in chat, is how do you spell this? It's spelled MLctl, and MLctl is, I think it's, well, I didn't know that it's, I think I heard it a couple of times. I thought, okay, why it's Cuddle? But, okay. Yeah.
I don't actually know either. I would like to know why we call it kubectl. Everyone just calls it that. Okay. I'm sure there's got to be some reason.
Yeah. Anyways, I was wondering, like, what led to Intuit? Like, what did you see that led you to think, okay, this is how we want to solve it. This is the tool we want to develop, and then yeah, eventually you decided to open source. So, what did you see there that led to this decision to create this tool?
This was born out of necessity at the company, because we use SageMaker for a few of the services in SageMaker. For example, model hosting and model training. We use Kubernetes. We have big Kubernetes shop, so we use Kubernetes for certain other things like batch inference. And we use our homegrown platforms for other things like feature engineering. And now you have these things in the ML lifecycle that the data scientist has to interface with. And we needed a way to bridge all of these so that data scientists have consistent experiences. So it was born out of necessity, and it's been used at Intuit extensively for ML lifecycle management. And that's when Alex and I have been chatting as part of, since our reInvent session last year, about, hey, how do we bring in cloud native ML ops tooling, and what does it even look like? And so when we were brainstorming about this, and like this MLctl is something that would definitely be useful in the open. So that's when we decided to open source it for the broader community to use. And
yeah, I would look at it from the alternative. I would look at the alternative within a large enterprise. For ML ops platforms. In an ideal state of the world, there's one tool that could do everything, whether that be a SageMaker, or you go to some of these startups. There's Domino Data Labs, there's H2O, there's DataRobot, and DataRobot just does acquisitions left and right nowadays, trying to own all the different pieces of the stack. But I think what I've seen time and time again, just yesterday I was on a call where we were discussing with a financial services firm. And then later that day, I was speaking to a startup that focuses on retail. It all have this Frankenstein thing that you described. So what's the next level best? If you can't have an end-to-end solution that does everything, what's the next best? Well, then you have all these different Frankensteins, and then the developers have to go learn for each use case, which of the Frankenstein parts how they work, but also like how they can do the API so that it can do the other steps of the model lifecycle, those big 8 stages once again. If you always have one path for a data scientist, i.e., so SageMaker for hosting, Kubernetes for training, and then your metadata is always done by MLflow, you're actually okay. You can just learn those tools and you're done as well. And then the next question then becomes like, how often can you stay within that happy path? It ends up being, for some, maybe you can, but I'd say for majorities, especially if you switch teams or there's a new business problem that needs to be solved, suddenly you're back to square one with to relearn everything. So like Srivathsan said, born out of necessity.
Yeah, thanks. So like it's, I don't know much about the company. It's like you have some internal product, like you're working on internal products, right? Or you're working on like outsourcing company, or what do you do? Yeah, Intuit. Like I'm just wondering what kind of profile the company has. It's like, are you working on like what kind of things you do?
So Intuit provides financial services for like hundreds of millions of customers. So we are the biggest tax software shop in the US and Canada. We also have QuickBooks, which is for maintaining the books of small businesses. So if you're a small business, you can use QuickBooks, and QuickBooks is available across the world in many countries. And Intuit also has personal finance management tools such as Mint and Credit Karma, which Intuit acquired recently as well. So Intuit as a company is in the finance and personal finance space with a mission to power prosperity around the world. So we are about how can we save money for you? How can we manage your books better so you have less waste, and how can we provide the maximum tax refunds for you in the interest of putting more money in the pockets of our customers. So in that context, we use a lot of machine learning to understand what the trends are, what the data is saying about the financial lives of our customers, and how can we make them better. Like if you are going to get hit with a finance charge for something, we know that it's coming because we can make predictions based on the data that we have. Or if you're a small business, if you want to take a small loan and make it contingent on a cash flow that's going to come, let's say 2 weeks down the line, we can do that because we have the data to predict that, yeah, you are going to receive X amount of dollars in the next few weeks. So we are okay to give you that loan. And in fact, Intuit does offer small business loans as well. So there is a lot of real world impacting machine learning that happens at Intuit.
Okay, yeah, I got it. So you basically have many different maybe products, many different teams working on many different projects. And then at the end, each team maybe has its own like a Frankenstein monster, because I guess most of the time these things were developing independently from each other, right? And you ended up having many different ways of doing things. And this is the problem you saw. And then you decided, okay, how do we make it easier to manage these things, right? And this is how MLctl was born.
And I think this is the story of most Fortune 100 companies. So I think Intuit's like 35 on that list. So they're pretty large in terms of scale. But all the other organizations that are have a large investment in data warehousing and analytics, like this is the next frontier for almost everybody. If you kind of Google through, I had a number of different logos up there and the names of their ML platforms that I was able to dig up through job descriptions, through public talks, or also through like papers or people that I've spoken with. The investment into these platforms, and by extension, the orchestration library, is quite strong. And that's why I started the SGTs. It's socialg.tech for anyone that wants to go see the website. We're trying to incubate a lot of these MLOps open source tools in the community. That way, enterprises aren't reinventing the wheel over and over again. You can imagine that every enterprise is probably figuring out a connector between SageMaker and Databricks for Spark and also their common ML train. And you can probably imagine that there's also Kubernetes on top of that as well. That becomes a very common recipe. We don't all need to reinvent the wheel, but we are at the current moment. And reinventing the wheel the first time isn't just the hard part. It's maintaining that wheel and then adding in the new ML functionality that comes, someone talked about Feature Store being the thing for last year. And we're now talking about ML orchestration. Probably next year, there's going to be a resurgence in XYZ, and that will lead to more and more investment that needs to happen in this library. We're really aiming to take an open source first perspective and also pull in the different pieces so we can augment the user experience while simplifying the platform maintenance.
Yeah, cool. What kind of tools, what kind of libraries you already have in there?
So we are starting with ML Cuddle. We've also been hosting community meetings on various standardization efforts. So within the APIs of one of the stages of MLOps, we started with inferencing. We've been trying to create a more robust community to unify the SDKs. So if you look at SageMaker versus Kubeflow Serving versus Selden, and then you can throw in another startup, they're all very, very fragmented. I don't think we're going to get to a spot where there's one, but can we at least decouple it so that the amount of opinionation goes down? Oftentimes, this is literally just validation that happens on the server side of like what schema inference endpoints have to do. So we've been hosting discussions and trying to build a compatibility test suite based off of some work that NVIDIA and several startups and open source projects have been working on. But outside of that, I think MLctl is really going to be the first accessible entry point that the whole spectrum of organizations can leverage. I think large organizations are going to get the most impact from this, but even startups, if you want to even leverage SageMaker, MLctl aims to be the best entry point in 6 months' time to SageMaker and Kubernetes, rather than even the existing SageMaker and Kubernetes like pods and CRDs, the SDKs that a data scientist would otherwise need to learn.
Mm-hmm. Okay. Yeah, the point you brought up about the different interfaces, that's interesting, because this is exactly what is on my mind right now at work. Like, this is what we think, okay, like there are so many different interfaces, like which one should we actually adopt? And like this one seems verbose, this one, like this is the process we are going through right now as well. So I'm really curious about that thing as well. So maybe you can share some links or some information about that, what you already did.
Yeah, I can send them over your way. One of the founders from NVIDIA of the inferencing specification says something really interesting about this, which I've been reflecting on quite a bit. It's the idea that the protocols themselves, no one really cares about. It's like thought of maybe a couple times by some platform engineer, and then they hook it all together in plumbing. But what the end user wants to access is a Python SDK or a Go SDK, or in some cases, even like a C SDK for that protocol. They want that abstraction as the end user. Mm-hmm. And that's why we started with MLctl as an entry point, because to even like connect all the different jobs, all you really care about is throwing in your model code, and then all the other pieces should just fall into place. Kind of like if I have Jenga, like those Jenga blocks, I just put all the pieces together, it forms this really nice tower, and it does the job. And then you break it apart bit by bit to have your fun. That's where I think the world can go, but we need these foundations to go in that direction.
Okay, thanks. So what's next for MLctl and in general for your initiative?
I think for us, we're aiming to get MLctl in several enterprises as pilots. So as an open source project, it's a very quick way to show how enterprises can leverage free tools within their organization to accelerate their velocity and development. And we want to make sure that we can knock out several common paths. So whether it be tabular data or amorphous data, classical ML versus deep learning, we're looking for several use cases within multiple enterprises to make sure that we can battle test the key concepts in MLctl, and specifically within the immediate technical roadmap. I think Srivathsan can address like some of the libraries and integrations that we're going for right now.
Yeah, we are in the short term, we are planning to integrate with make our SageMaker integration GA and integrate with Azure ML and Kubernetes. So you have 3 different ways of you can do some of the MLOps lifecycle stages, and then continue with adding more stages. Like I think we'll be offering 3 or 4 of the big 8, and then expand to offer more in the later. And we'll also be integrating with GCP Vertex after the initial short term.
So think about this in 2 ways. There's the providers for the infrastructure that we need to connect to. There's also the client access points. The client access points are either CLIs, a Python SDK, or within a tool like Airflow or Kubeflow pipelines as nodes within your step. And then on the flip side, for the providers, it's where the infrastructure runs. So that's the GCP Vertex, the SageMaker, the Kubernetes, the Databricks Spark runtimes versus the Spark on Kubernetes operator, or something like Azure ML that has just a few of the ML pieces, but not quite the whole story either. We look at this basically two sides of a quote marketplace, and we need to have like the right paths, not just for the tooling choices, but also like the right semantics for a type of model or a type of data that you want to flow through. So there's many different elements that introduce complexity here. But at the same time, I think what's beneficial for us is we have a great enterprise that's trying to open source what they've already used internally. And also on the SGT side, we have a number of different enterprises within our network that we've regularly talked to in terms of figuring like what are the pain points for them today and what can we do in open source to really tackle some of those challenges to increase velocity. A lot of these tools, vendors are just not willing to build because it goes against their walled garden or their moat ecosystem. These tools always must emerge just because every enterprise thinks about portability and not being locked in with one tool and really taking advantage of best in breed at some point in their development journey, regardless of what market this is.
Yeah, thanks. Well, I guess we should be wrapping up. I don't know, do you have anything else you want to say before finishing?
No, I think that's it.
Well, then I want to thank you for joining us today, for telling us, for sharing that with us, for also telling about MLctl CTL. Yeah, it would be. It's actually possible to try it on right now, right? So, okay, I saw that there is a GitHub repo. Is it actually possible to try it right now?
There is a GitHub repo. It's work in progress,
Okay.
and we are making a lot of changes as we speak.
Okay.
So,
maybe not right now, right?
Not right now, but maybe in a couple of weeks. Yes.
Okay. Yeah. So thanks a lot for joining us today and for your chat, and thanks everyone for listening in and asking questions. And yeah, thanks. And we have another talk on Friday. Don't forget to join.